Kid and back with another video, and this is the continuation of offensive hacking and exploitation. In this video we will do the rest of the exploitation and we will find out what are those things which break the shellcode on the runtime. In previous video I show a diagram where shellcode is one of our main part of the exploitation. Now what are shellcode? Shellcode is the machine instruction which further need not to compile, so it can be injected directly into memory which give a shell into victim machine. It is totally over attacker intention what kind of shellcode he use in his exploit. Now let's get back to our demo section and do the rest of the exploitation. Okay, now we are back in our lab setup. Now let's create the actual exploit. Let's open the server script. Now first 4116 byte will be our edge. After that EIP will point to our shellcode and then the actual shellcode will be inserted within the stack. Okay, now we need to generate our shellcode. So I will use MSA Venom to do that. Let's type MSA Venom. Our payload will be Windows shell bind TCP. Here I will use bind shell. Now the architecture is x86 because we are exploiting 32-bit machine. x86, and after that we need the shellcode in C array format. Now hit and enter. Now our shellcode is generating. Now we just got our shellcode. I need to copy this entire shellcode and paste it within our server. Let's clean this up. Now paste it here. Now what will be the address which override the EIP? The address will be the shellcode. Okay, now let's find out the address of shellcode. We already found it in our victim machine. Let's go to our victim machine. Now if you can see, this is the address where the ESP is currently pointing to. Now let's write down this. Paste it here. Now let's get back to our attacker OS and write down the address. To maintain correct EDNS, we need to give the address in reverse order. We already do this in part 1 of this series. Let's write down. So what will be the address? Okay, 28 C8 C8 4702 4702. Now next we need to give some amount of knobs for smoother landing. So now the hex code of knob is 90. So let's write down 10 of them will be good. Now we need to send all of this together. Now first will be our buff, then EIP, after that knob sled, and then this is the position of the shell code. Now our server is ready to deploy. Let's save it, run our server. Let's get back to our victim machine, open the NFTP, attach with the process. Now open the malicious link 192.168.43 and 180, and port number will be 5000, and hit and enter. And now if you can see access violation when executing the following address. Now here is the problem. After we point to our shellcode, program should be running, but the access violation happened. Let's inspect what's wrong with the program. Now here we send our all A's. After that, this will be the address which will point to our nope instruction. Then our shellcode should start, and this is the address where our shellcode is located. Now let's find out what are our shellcode. Now first is FC-E882. Okay, and you can see exactly same here, FC-E882, after that 0023, and if you can see that here is 30, but all three zeros are not here, and this is the problem. This is seems like our shellcode got broken after pushed into the stack. Let's find out why this is happened. Okay, the reason behind why our shellcode broke on runtime is the bad characters. Now what are bad characters? Now this is the character which is responsible to break our shellcode. Now delimiters is one of those elements which is responsible of bad characters. The common delimiters are string termination, which is 00. Also there is other bad character as well, like /r/n. Also depending upon how the application is developed, the bad character can be anything. Now we need to find a way to find out the bad characters which break our shellcode. So let's jump to our demo section and do that. Now what we will do, we will send all the possible hex character to the program and find out what are those character which breaks our shellcode. Okay, let's create all hex characters. Let me exit this. Okay, I already wrote a program which is called batcare.c. This program is print out all the possible hex character. Okay, now let me compile this using GCC. Okay, compilation is completed. Now let's run it. And here it is. This is all the possible hex character. Let me copy this and paste it into our server. We don't need our shellcode for now. Paste it here. Now let's run our server. Okay, let's go to our victim machine. Run NFTP. Attach it with the process. Open the malicious link. Now the crash happened. Okay, let's inspect the memory. Now here is our all A's. After that the EIP, and this is nope. And after nope instruction, our bad character should start from here. But you can see that here is our first bad characters, and after that the all things seems broken. Now here we get our first bad character is 00. This is also called null byte. So let's write down. Now let's get back to our attacker machine. Exit the server. Let's modify our server. Now what we will do, we will send all those characters except the first bad character, because we already found that this is the character which breaks our shellcode. Now let's run it. Now our server is running. Let's get back to our victim machine. Restart the program. Now our program is running. Open the link. Hit and enter. Now the crash happened again. Now let's find out in memory. Okay, here is our all A's. After that nopes. Now here are all hex characters. Okay, it start from 01, 02, 03, 4, 5, 6, 7, 8, 9. After that, after 9, it seems broken. So /x0a is the second bad character we have. Let's write down. Let's get back to our attacker OS. Wait it. Modify our server. Now here is the bad character /x0a. Remove it. Let's save it. Okay, let's run the server. Now our server is running. Let's get back to our victim machine and restart the program. Now our program is running. Open the link. The port number is 5000. Let's hit and enter. Now the crash happened. Let's see it in the memory. Now here is the nope instruction. After that our all hex characters are here. Now you can see that here 0D is missing. So this is also a bad character, because if our shellcode has a 0D, then our shellcode will break on the runtime. Let's write down restart the program again. Now our program is running. Let's get back to our server. Modify our server. Save it. Let's run our server. Now our server is running. Let's get back to our victim machine. Open the link. .180 and the port number is 5000, and the crash happened. Let's find out in the memory, and you can see the all hex code are here. And end with FF. These three is our bad character, so we need to remove it to run the shellcode without any problem. Okay, that's it for this video. In next video we will recreate the shellcode without this bad character and do the rest of the exploitation. If you really like this video, give me a thumbs up, share among your friends, and I really appreciate your comments.